Assalamualaikum and greetings. We from Group 1 will present assignment 2. We choose mission 3 for this assignment. Introduction, pulse modulation. Digital signal transmission requires a signal which is in the form of binary or pulse signals in discrete form. Pulse modulation is divided into two. First, pulse analog modulation. Second, pulse digital modulation. There are three types of pulse modulation. First, pulse amplitude modulation, PAM. Second, pulse width modulation, PWM. And the last one, pulse position modulation, PPM. Multiplexing. Process of transmitting two or more signals simultaneously is known as multiplexing. The main objective of this system is to increase the capacity of a transmission channel. Four multiplexing methods. First, frequency, FDM. Second, time, TDM. Third, space, SDM. And fourth, wavelength, WDM. Pulse amplitude modulation, PAM. PAM output signal is a signal sampled from a peak flat sampling which assumes a much smaller pulse width than the pulse. Therefore, the mathematical representation and the PAM modulated signal spectrum are similar as the output signal spectrum sampler. PAM signal are easily generated using multiplier circuit or telemetry switch, while PAM signal detection can be implemented using low pass filter, LPH. Pulse width modulation, PWM. PWM is also known as PDM, pulse duration modulation, or PTM, pulse time modulation. PWM waveform consists the pulse with the same height, same duration, but varies the width according to the instantaneous signal. Equation 4.13 shows the equation for the spectrum of PWM signals. The pulse width value of PWM signal is changing to produce the sideband frequency components, and it matches with the signal spectrum, NBFM. PWM signal generation is to convert the PAM signal voltage sample to a specific period. PWM signal noise is less disturbed than PAM signals, resulting in greater usage among the application which use PWM modulation is a direct current motor controller and the controller light intensity. Pulse position modulation, PPM. In contrast to the PAM and PWM modulation, PPM waveform is obtained from the pulse signals that have the same height and width but have varying period according to the value of the instantaneous signal. PPM signal is generated from PWM signal. To obtain the signal at the receiver, the PPM signal needs to be demodulated to PWM form before being filtered using a low-pass filter. Figure 4.19 shows the generator and detector PPM signal. PPM modulation is widely used in many applications for narrowband RF channel which has low power. For example, it is used in the radio signal control model aircraft, boats, and cars. Modulation is used because it is easily decoded, resulting in the receiver circuit becoming more compact and small.
So now we are going to see who is accredited with defining the sampling theorem. As we all know, the sample rate must be at least twice the highest frequency. The correct answer is NQS, which is Harry NQS, known for the NQS theorem, which explains the to accurately capture an audio signal, we must sample it at least twice its highest frequency. This ensures that no information is lost during the digital recording process. So sampling is the process of taking measurements of an analog audio signal at regular interval. So for example, when we speak, the sound is smooth wave, which is analog. To convert this into digital form, we must sample it, which means we measure the height of the wave, which is amplitude, and at the specific time, which is intervals. So the more often you sample, the more accurate the digital version of the original sound. According to the NQS theorem, you must sample at twice the highest frequency in the audio to preserve the sound accurately. So let's say if your audio has a frequency of 10,000 Hz, you need to sample it at least 2,000 times per second to get audio to preserve the sound accurately. Following, in digital audio, bit depth is defined as which of the following. So as we all know, the correct answer is the number of bits of information in each sample. Bit depth determines how detailed each audio sample is. A higher bit depth gives you a better sound quality because it captures more detail from the original sound wave. So as we all know, we calling as a coding. So the definition of the coding, also known as a quantization, is the process of the converting those measured sample just now value into the binary numbers, first and zeros. After you take a sample, you must assign it a digital value. This is called quantization or coding. Bit depths matter here because bit depth tells you how many bits are used to represent each sample. For more bits, equals to more details or more better sound quality. For example, let's say we have a 8-bit audio, gives you 256 possible value per sample. In the other hand, if you have a 16-bit audio, it will give you 65,000 plus value, which means much smoother and clear version. So so sampling measures the sound at the intervals. In the other hand, the quantization turning those measurement into digital data. Both are critical steps in converting the analog sound into digital audio. Thanks.
I'm going to talk about the multiplexer, a technique used in communication system, transmit multiply signal over a signal transmission channel. I explain what multiplexing is. It's a different type of their application. So what is multiplication? It's a process of transmitting two or more signal similarly over the same transmission channel. This method is used to increase the capacity of the efficiency of the communication system. There are four main type of multiplexing method. First, frequency division multiplexer, wavelength division multiplexing, space division multiplexing, and the time multiplexation. First, frequency division multiplexer or FDM. This method can be used in both analog and digital systems. It's work by transmitting multiply signal at a different carrier frequency over the same medium. Each signal operates within its own frequency band, which help avoid the interference. So next is a wavelength division multiplexer or WDM. This is mostly used in the fiber optic system and operate at a much higher frequency than FDM. Here's the different signal are transmitted using different wavelength or colors of the layer through the same fiber. The ITU or International Telecommunication Union set a standard grid for this. WDM is divided into type like a CWDM, which is more for efficiency, effective, or access network, and DWDM, which allow for very narrow spacing between wavelength and is used in core network where traffic is heavier. Moving on to space division multiplexer or SDM, this method involves using multiple physical pads such as multiple cable to transmit a signal. Although this increase the cost and can lead to the bulkiest cable, it offers easier maintenance and reliability. Even if one cable fails, the other channel can be continued to operate without the interrupt. Now let's talk about the time division multiplexing or TDM. This technique is mostly used in the digital system. Here, multiple signals share the same carrier frequency, but each is allocated a different time slot. It's worked by dividing the total time frame into a smaller time slot and combining several sample signal in a specific time sequence. In conclusion, multiplexing helps improve the efficiency of communication system by allowing multiple signal to share the same medium. So first, WDM used a different waveform color of light ideal for the fiber optic. SDM used a separate physical pad, example multiple cable. FDM used a different frequency band common in radio and TV. And TDM used a different time slot suited for the digital system.
Hello everyone. Now I want to share why unlimited access to all types of information is not a positive impact of telecommunication technology. Telecommunication has many good points. It helps us work faster, saves money, and allows us to work from anywhere. But having access to every kind of information is not always good. First, for health. Some information in online can be dangerous or fake, especially about medicine or health advice. If people believe wrong information, it can harm them. Next, for safety. Some information is not safe for everyone, especially children. They might see violent or harmful things or get scammed in online. That's why we need filters and controls. Then, for legal reasons, some information is private or protected by law. We can't access government secrets or someone's personal data. There are rules to protect this information. Finally, in culture, what is okay in one country might not be okay in another country. Some content can hurt feelings or go against local beliefs. That's why every country has its own rules. So